Myself, Dr. P. Soumya, working as an assistant professor in the Department of Chemistry, Institute of Aeronautical Engineering College. Today, I'm going to discuss about potable water and what are the specifications of potable water and what are the steps involved in treatment of water. So, in this, I'm going to cover what is potable water, what are the specifications of potable water, what are the steps involved in the treatment of potable water. So, what is potable water? The potable water that has been treated and tested as safe for human consumption, also known as drinking water. So, potable water, that has been treated and tested as safe for human consumption. So, the water which is used for consumptions of human, that is called as potable water. It should be tested as safe for human consumption. So, this is also called as drinking water. So, this is also called as drinking water. So, this includes tap water, bottled water, filter water, and any other water considered safe for drinking and food preparation. So the potable water includes tap water, bottled water, filter water, and any other water that considered safe for drinking and food preparation is called as potable water. So specifications of potable water. So the water should be clear, colorless, and odorless. The potable water should be clear, colorless, and odorless. So the turbidity should not exceed 10 ppm. The turbidity in water should not exceed 10 ppm, and the total dissolved salts, so that is TDS, should not exceed 500 ppm. So TDS should not exceed 500 ppm, and the hardness of water must be 125 ppm. The hardness should be 125 ppm, and pH of this potable water, so this is 7 to 8.5. 7 to 8.5. So the water should be free from heavy metals like lead, arsenic, chromium, manganese, and dissolved gases such as H2S and sulfur dioxide. So it should not contain metals, heavy metals like uh, arsenic, lead, chromium, manganese, and dissolved gases such as H2S and SO2. So H2S and sulfur dioxide gases. And the water should be free from pathogenic microorganisms. So which causes the diseases? This should be free from pathogenic microorganisms. So water should be clear, colorless, and odorless. The turbidity should not exceed 10 ppm. The TDS should not exceed 500 ppm. The hardness of water should be in the limit of 125 ppm. The pH must be 7 to 8.5. And the water should be free from heavy metals and also free from pathogenic and microorganisms. So what are the steps involved in the treatment of potable water? So in this, first step is screening, sedimentation, coagulation, filtration, disinfection. Screening, sedimentation, coagulation, filtration, disinfection. So these steps are used for the treatment of potable water. Treatment of potable water. So the type of treatment is given to water largely depends upon the quality of raw water and also upon specified standards. So this the treatment is depends upon the quality of raw water. So we will take this raw water from lakes and rivers. Lakes and rivers. So different lakes and different rivers have different impurities. So the treatment is depends on the quality of raw water which was taken from the different places and different rivers and lakes. So these steps involved in treatment water is two types. So that is removal of suspended impurities, and second one is removal of microorganisms. Removal of microorganisms. So first step is we have to remove suspended impurities which are present in water, and we have to remove the microorganisms which cause the diseases to the human being. So for removal of suspended impurities, first we have to do screening. So what is screening? The raw water is passed through screens having large number of holes. So these raw water is passed through the screens which are having large number of holes. So where the floating materials, where the floating impurities are retained at the screens. Retained at the screens. So this is the screening process. In this we are using the screens which are having large number of holes where the floating materials are retained. So next step is sedimentation. Next step is sedimentation. In this is the process of allowing water to stand undisturbed in big tanks. So this water is undisturbed for certain time. So these are keep in undisturbed big tanks about 5 meter deep when most of the suspended articles settle down, and suspended impurities are settled down at the bottom due to force of gravity. So this is the process of, first in this process we have to keep the water without disturbing the water. We have to keep in big tanks, so that is about 5 meter deep. So then the suspended impurities which are present in water, they will settle down. So simple filtration, or we can remove the suspended impurities easily by sedimentation process. Due to this sedimentation process, we will remove the bigger particles. We will large or bigger suspended impurities. Large or bigger impurities from the water. So this is the sedimentation process. In this, water is keeping undisturbed. Here, next process is coagulation. So sedimentation with coagulation is a process of removing fine suspended and colloidal impurities. So in water we will have clay and sand impurities. So these are called as fine suspended impurities. Fine suspended or colloidal impurities. So by the addition of coagulants to water before sedimentation, so that process is called as sedimentation with coagulation. So here we are using chemicals or coagulants. Chemicals are coagulants, so which are treated with water to remove the finely suspended or colloidal impurities like clay or sand. So usually this clay or sand, this will have negative charge. So this will have negative charge. So when we adding this coagulants, this will have positive charge. So when this two will combine each other, and this will form neutral molecules. These neutral molecules. So these neutral molecules again combine together and they will form larger molecules. They will form larger molecules. So they will settle down as a flocculant. They will settle down as a coagulant. They will settle down as a flocculant or precipitate or a sediment. So this process is called as coagulation. In this we are using chemicals or coagulants for the coagulation process. So this coagulant when added to water form insoluble gelatinous flocculant precipitate which descend through the water. So absorbs and entangles very fine suspended impurities forming bigger flakes, so which settle down easily. So by this coagulation, we are removing fine suspended or colloidal impurities by addition of coagulants. So examples of coagulants are potash alum. So what is the formula here? Potassium sulfate, aluminium sulfate 24H2O. So this is formula of potash alum. So this is used as a coagulant. So another example is sodium aluminate. Sodium aluminate. So we can use copper or ferrous sulfate as a coagulant. So examples of coagulants are potassium, sodium aluminate, ferrous sulfate. So when we use this sodium aluminate for treating water, so this will treated with water and it will form aluminium hydroxide. So this will it will form flocculent PPT, flocculent precipitate. So solid will form precipitate. So it will form sodium hydroxide. So when sodium aluminate reacted with water, treated with water, this will form aluminium hydroxide. So that is precipitate and also sodium hydroxide. So these aluminium hydroxide flux cause sedimentation. They sedimented at the bottom, and the sodium hydroxide that produced precipitates magnesium salts such as magnesium hydroxide. So this sodium hydroxide, this will precipitate. This will form precipitates with the magnesium salts like magnesium chloride, magnesium sulfide, magnesium nitrate. So like that. So nitrate, magnesium nitrate. So like that. So they will form precipitates with the magnesium salts which are present in hard water, which are present in water. So this will form magnesium hydroxide PPT precipitate. So these both precipitates were settled down at the bottom, so we can remove easily by the water from the water. So this is about coagulation. So next step is filtration. Next step is filtration. In this process, this process is used for the removing colloidal matter and most of the bacteria, microorganism by passing water through a bed of fine sand and other proper sized granular materials. So from this process, we can remove colloidal matter and most of the bacteria, that microorganisms. So both colloidal matter and microorganisms can be removed by using filtration process. So by passing this water through the fine filter. So that is made up of a bed of fine sand and other proper sized granular materials. See here, this is a filter. In this fine sand layer, this is covered with, this is placed over a coarse sand. This fine sand is placed over a coarse sand, and this coarse sand placed over a coarse or fine gravel. So this coarse fine gravel is placed on large pebbles. So this is the construction of filter. So lastly, we will have one cotton or any cotton plug or cloth. So we will use now some pores. This will have some pores. So this is the construction of filter. So first we have to take fine sand. This is placed over a coarse sand. Next coarse sand. This coarse sand is placed over a gravel. So this gravel placed over a large pebbles. So this is the filter. So this filter is used for the filtration of water to remove the colloidal matter and most of the microorganisms. So second process is removal of microorganisms. Till now we will remove suspended impurities from the water. So second is removal of microorganisms from the water. So that is also called as disinfection. So what is disinfection? The process of destroying or killing the disease producing bacteria, microorganisms, etc. from the water and making it safe is called as disinfection. Here, the process of destroying or killing the disease causing bacteria, microorganisms, etc. from the water. So that is called as disinfection. So many processes are there. for disinfecting process are many processes are there. First one is boiling. Simple process is boiling. So that is we have to boil the water 10 to 15 minutes and all the disease producing bacteria are killed and water becomes safe for use. So by boiling water, so we can kill the disease producing bacteria. So then the water become safe for use. This is the uh, simple and oldest process of disinfecting the water. Here, second one is bleaching powder. So the purification is achieved by dissolving 1 kg of bleaching powder in 1000 kiloliters of water. So we have to add 1 kg of bleaching powder in 1000 kiloliters of water. Kiloliters of water. Then only the microorganisms which are present in water killed by bleaching powder. So when the dissolved water produces a powerful germicide, that is hypochlorous acid. When the formula of bleaching powder is CaOCl2, when it is treated with water, so it will form calcium hydroxide and chlorine. So this chlorine again reacts with water and forms HCl and HOCl. So this is a powerful germicide. So that name is hypochlorous acid. So HOCl is hypochlorous acid. Hypochlorous acid. So this is a powerful germicide. Means this will kill the germs which are present in water. So when germs are the germs are treated with this bleaching powder, germs are killed by the bleaching powder. So which is the active component is hypochlorous acid. This will kill the germs which are present in water and then water is said to be purified. So water is said to be purified. So this is the process of removing microorganisms from the water by using bleaching powder. So next technique is chlorination. So in this we have to take direct chlorine gas to purify the drinking water. So this is the process of purifying the drinking water by producing a powerful germicide like hypochlorous acid. In this case we are using direct chlorine gas. Chlorine gas, when this chlorine gas is treated with water, so we will get HOCl and HCl. So we know that this is a powerful germicide. Powerful germicide. So this will kill all the microorganisms which are present in water. So here we are taking chlorine gas to remove the microorganisms from the water. So this process is called as chlorination. Here the chlorine is a basic. The chlorine is basic means the pH of chlorine is more than 7. So this ion is much effective over the germs. Hence chlorine is widely used all over the world. A powerful disinfectant. It is called as powerful disinfectant. So chlorinator is an apparatus which is used to purify the water by chlorination process. For chlorination process, we are using chlorinator. So by using this apparatus, we are doing chlorination to kill the microorganisms, to kill the germs which are present in water, uh, to to remove the germs. So next step is ozonization. So ozone is powerful disinfectant and is readily dissolved in water. So what is the formula here? O3 is ozone. So this is also called as powerful. This can act as powerful disinfectant and it is readily dissolved in water. So ozone being unstable, it will decompose by giving nascent oxygen. So and it is capable of destroying bacteria. So when this is ozone is unstable, so it will form oxygen and this will form O2 and elemental oxygen, that is also called as nascent oxygen, so which is capable of destroying bacteria. So the nascent oxygen removes the color, taste of water and oxidizes the organic matter present in the water. So these oxygen, elemental oxygen, are nascent oxygen used for the oxidation of organic matter which is present in water, and also it is used for the killing bacteria and microorganisms which are present in water. So this is acting as a powerful disinfectant as well as oxidizing agent because it is very stable and it will form nascent oxygen. So this ozone removes iron, bacteria and viruses, hydrogen sulfate from the water and also manganese from the water. So this is ozonization. So last technique is breakpoint chlorination. Breakpoint chlorination. So the chlorine, this breakpoint chlorination is a controlled process. So in this process, suitable amount of chlorine is added. Here, certain amount of chlorine is added. Certain amount of chlorine, suitable amount of water, which is suitable for water, what we are taking. Here, in order to kill all the bacteria present in the water, to oxidize the entire organic matter, and to react with free ammonia, the chlorine required should be appropriate. So here, by using breakpoint chlorination, we will remove the bacteria. So this will treated with bacteria, and also it is used for oxidizing organic matter, and it is also reacted with ammonia. So when water is having bacteria, organic compounds and ammonia, so this breakpoint chlorination is very useful for removing all the impurities at a time. So we can remove the bacteria, we can remove the organic matter and we can remove the ammonia. So here, so this breakpoint chlorination is used for in order to kill all the bacteria present in water, to oxidize the entire organic matter and also to react with the free ammonia. So this process is very useful for this process. Here breakpoint determines whether chlorine is further added or not. Here breakpoint is determines whether the chlorine is further added or not. Here by chlorination, organic matter and disease producing bacteria are completely eliminated, which are responsible for bad taste and bad odor in water. So by this breakpoint chlorination, organic matter, disease producing bacteria completely eliminated, which are responsible for bad taste and bad odor in water. So when certain amount of chlorine is added to the water, it leads to the formation of chloroorganic compounds and chloramines. So when it is having organic compounds and organic compounds and ammonia. So when water is having organic compound and ammonia, so we have to add certain amount of chlorine, certain amount of chlorine, the particular amount of chlorine. So then this will form chloroorganic compounds with organic compounds, and this will form chloramines with amines. Chloramines with ammonia. Chloramines with ammonia. So this will form during the breakpoint chlorination. So the point at which residual chlorine begins to appear is called as break point. Here, first we are adding certain amount of chlorine, then so it is forming trichloro, trihalomethanes, monochloramines. Means it is forming chloroorganic compounds as well as chloramines. So after one point, the residual chlorine is increases. So this is indicates the completion of organic compounds and microorganisms and also ammonia which is present in water. So when the point at which the residual chlorine concentration increases, so that is called as break point. So that point is called as break point. So the addition of chlorine after the break point, so that is called as break point chlorination. So this break point chlorination technique is used for the removal of bacteria and also organic compounds, ammonia from the water. So these are the steps involved in the water, uh, involved in the potable water. Thank you.
Like, share and subscribe. Hit the bell icon for more updates.